Welcome to the future. Technologies and innovations that sculpt our industry. This episode brought to you by Hitachi. You call it harmony, we call it air. Learn more at hitachieaircon.com. All right, everyone. Thank you for joining us once again on Did You Know, the ESCO HVAC podcast. So this time we have the wonderful opportunity to spend some time with Enes Uzel. How are you, sir?
Good, thank you.
So Enes is the VRF product manager for Hitachi, and we are all starting to become more aware of the technological transitions that we are in, as well as refrigerant transitions. There's a lot of things that are happening in the industry, and it's a very exciting time. But with that also comes the awareness and the education and the training on these new products. And so in the VRF market, you have a new product that is getting ready to hit the ground called the Air 365 Max. Tell me a little bit about this new transition in the VRF side of things.
So for Air 365 Max, this is going to be our latest and greatest Gen 3 product, and we're going to brand it under HeatForce. As you know, with the heat pump transition, there's a huge demand for heating products. So our current VRF lineup can do heating down to minus 13 Fahrenheit. Okay. And we are expanding that heating range down to minus 22 Fahrenheit. And we are introducing the first vapor injection compressor with Hitachi. I'm not sure if you have read about Hitachi's background on compressors, but Hitachi was the first company to invent the scroll compressors, which is widely used in the industry today. So we are taking that a step further, and now we are introducing vapor injection inverter scroll compressors for VRF products. So we have just launched this product, and we have it available for sale in the market. And we have the training center, we have set up the product, and we have very new features that's also coming with the product called AirCloud Tab, where you can connect to the outdoor unit and the indoor unit with your phone and do variety of function selections. You can read data from it. You can program the unit, all the dip switch settings. You can do all those things from your smartphone.
Wow. I'm very excited about that. When we start talking about innovations in equipment, we don't always talk about the innovations in the digital technology that comes along with that. Exactly. And I'm very much about non-invasive diagnostics, not using refrigerant gauges until you think you actually have a refrigerant problem. Utilizing our inputs from our thermistors and our pressure transducers and understanding how these systems are operating. And now we're actually doing that directly from the input from the app, right?
Exactly.
I'm like
so it's very, when you look at the VRF, everybody's at first intimidated by amount of technology that goes into it. It's very labor intensive. They think it's a lot of, like you said, pressure transducers, thermistors, pressure sensors. There's a lot of valves and checkpoints, but at the end of the day, it makes life that much simpler because you can read data from all those things via your service checker, or now we are introducing the AirCloud Tab. You can read the data with your smartphone throughout the unit. You can see all the data points from your smartphone.
Without plugging in a laptop and a cable and looking for a charging connection.
Exactly.
I always make the analogy to the transitions that we made in the automotive industry a couple decades ago. There was a time where a lot of technicians can work on a variety of different manufacturers of equipment, and they were hands-on. They were having to use a lot of tools to be able to, analyze timing of an engine and fuel mixtures. Well, now as we move into digital technology, we're making that same leap where we're using all of the inputs that are within the components themselves to analyze what those outputs are, have a better understanding of how it's operating. And I really look forward to these next generations of technicians that are using this technology for fine tuning. They're using it for installation and commissioning. And so we get these really high performing systems that are actually quite intriguing to work on, instead of now what we used to look at as challenging. It's now intriguing and enjoyable.
Exactly. So, right now, when you have a VRF unit, you have an error code, and all you have is a very old style
Yeah.
7 segment
I got a
display.
blinky light. I got a
Yeah,
binary code.
exactly.
Where do I begin?
You have to read the code, you have to go to your engineering manual, see
Yes.
what's going on, and figure out the issue, what
Yeah.
that code
Yeah.
means.
Work through my
You,
workflow.
you start diagnostic the unit and then work backwards and fix the unit. But with the AirCloud tab, what you can do, you don't even have to open the panel to look at the 7 segment display, which
Really?
already we keep that there for
Right.
backup. But what you download the AirCloud app on your smartphone, you bring it next to the condensing unit. There is a little plastic port. It
Mm-hmm.
has a little NFC symbol. So
Oh,
we
yeah. Near field
utilize,
connected.
yes,
Oh, fantastic.
we utilize a near field communication
Yeah. Yeah.
technology, and that you bring your phone close to. It's like checking out with an Apple Pay.
Yeah. Absolutely.
You bring
Same
your iPhone
process.
to that area, and then it starts pulling the information from the unit. So not only you can read the error code and find out what's the error code mean, but also you can get 5 minutes of data prior to the error code, so you can see what was happening and what led to that error code. What led
Wow.
that? It was at a higher
Yeah.
pressure. Maybe
Exactly.
you were leaking refrigerant
Yeah.
somewhere, and
Yeah.
your pressures were low. You can
Yeah.
diagnose the units based on the information you're pulling from the
Oh
condensing
my
unit.
gosh. We talk about the lack of technicians that we have, the amount of technicians we need to bring into the HVAC and refrigeration industry. And I'm a big advocate of, well, yeah, it's always nice to bring in more people. If we could make our people more efficient by utilizing technology, that's the whole key. I mean, think about that. If I had a high pressure scenario and I could go back 5 minutes and go, oh, high current on condenser fan motor. I just lost
Yeah,
a condenser fan motor that caused my high pressure. Let me start my condenser fan motor and check this before I even get into refrigeration cycles. It could just save so much time when it comes to troubleshooting.
exactly. Also for commissioning too. So
Yes.
again, for VRF systems, we have tons of dip switches on the PCBs.
Yes.
So depending on your setup, how you're setting up the connection ratios, what type of indoor units you have, how
Mm-hmm.
many modules of
Line
outdoor condensing
sets.
unit,
Yep.
all these have to be programmed via dip switches.
Right.
But we are eliminating that step. They don't have to take out the front panel, get into dip switch settings. They just have to do those settings on their smartphone, and they can copy and paste settings between different condensing units. Be it 50 condensing units, they literally copy and paste the same settings.
You got to be kidding me.
Yeah,
I'm
it
really
saves
excited to see this.
it saves tons of hours for commissioning and initial installation.
Yeah, and that's always the thing. When we look at that stigma of walking up to a VRF on an installation and commissioning, a lot of technicians go, oh man, I've got all of these settings that I go through. And typically when I do an instructional class, I go, well, they're there if you need them. And we have things that we need to change because we are going to do a custom setup for this particular application. And don't be afraid of all of the options. You just be aware of what they are so that we know what ones we need to adjust going into this custom installation. And so by utilizing that where we can actually connect to the piece of equipment, we can do our setups. It lets us focus on the total system instead of getting detoured into manual dip switch settings and
Yes,
binary code retrieval.
and our technical service. So, for instance, if something is wrong with the dip switch settings, right? We have a technical support center based in the Dallas, Texas area. They reach out to our tech support, and dip switch settings are wrong. So, our tech support can literally fix the dip switch setting on their end and send the new setting to the contractor on the field. And from his phone, he can push those settings
Push
into the
the update.
condensing unit.
No kidding.
So yes, we can directly interact with the condensing units from our technical support center here in Dallas, Texas.
I've been looking forward to this technology for so long.
It's amazing.
It really is, so that we can look at things in real time. And we've been playing with this software for a number of years. And it's just, a lot of times we had to have right connections, we had to have the right cellular connections. And now when we start talking about near field communication, it just makes that so much easier and faster to do that direct connect link. So yeah, very, very intrigued about that. And we're talking about a system when you were mentioning like the vapor injection working at minus 22 operating conditions. That's bringing in a new level of efficiency that a lot of people can't even really wrap their head around. Because now we're talking about COPs that are even above 5. We're talking about a COP of up to 5.12 on this piece of equipment.
Exactly.
That's a lot of efficiency.
So yeah, that was the main aim when we came up with this product. It's actually Hitachi Air 365 Max Heat Force. So
Okay.
the reason we call it Heat Force, it has amazing heating performance. Like you mentioned, it's 5.1 COP, and down to minus 13, we still offer 100% of our rated heating capacity.
Really?
And at minus 22, we can maintain our 88, 89% of our rated heating capacity.
You've got to be kidding me.
Exactly.
That's the future of our industry.
Yes. So I'm seeing a lot of other heat pumps that can go down, but they're not able to push that much of COP. So
Yeah,
you have a heat pump. If you're 1-to-1 COP, you might as well use a electric heater, right? If your
absolutely.
COP is so low,
That's it.
the reason of switching to heat pump is that efficiency, that high COP. So when you go down to minus 22, minus 15, those kind of temperature, if you can maintain the high COP and your heating capacity as high as it's rated initially, that's an amazing product. That's what I will look for if I'm purchasing a heat pump product.
Yeah, I absolutely will as well. So when we start talking about reducing our carbon footprint, when we talk about there's a variety of different terms we can utilize for electrification, degasification, decarbonization. It's really about making a global effort to reduce our energy consumption, to push to new product capabilities. And I've seen things like our DOE's initiative for the Cold Climate Heat Pump Challenge, which has encouraged our OEMs to start pushing the boundaries in
Mm-hmm.
technology and innovations. And this is it. This is
Yes.
what we have been striving to get to.
This exactly. This product we are really happy to announce. Like a Hitachi brand name, all of our products are tested for reliability for those low temperatures. In order to maintain those high capacities, we really have to push our compressors to its limits, and we have had a lot of issues with the compressors to get it to this point
Yeah.
where they are reliable and operates for years and years without having any issues. So we got those compressors pinned down. Our designs are reliable. All of Hitachi product, especially VRF, they're all made in Japan with the quality control and the reliability test that it's been through. And this product recently is launched, and we have it available for our customers to order as of today.
Awesome. Fantastic. Well, I really appreciate that. I'm so excited about the transitions that we're making in our industry. And I think we're going to take the opportunity to bring Bahadir in. And we're going to talk about the transitions that we're making in the residential sector, because you've got a product that intrigues me in a couple different perspectives. Bahadir, how are you, sir?
Thank you so much. Thanks a lot for this opportunity. How about you?
I'm doing well. I'm really excited about the way that we're going to be looking at our industry going forward in the residential as well as the commercial industrial sectors, but in the residential particularly. I'm a big advocate of monoblock air to water transitions in our industry. If we're going to make this transition happen, we have to start looking and thinking outside of the box.
Correct.
And the new Hitachi really kind of does that.
So the question is, how is it moving forward? The fact is, the way that we have decided to think about Hitachi, because Hitachi was a line card for our European region for at least 1 decade, and we were doing a great job in Europe, but for US market, it was always a kind of question mark in our minds. But as time goes by, as you know, things are changing very quickly. Yeah, and each and every change means problems, and each and every problem means a solution. Each and every solution means opportunities. So the first and foremost, electrification, because we knew that electrification means tons of changes in regards to different disciplines. First and foremost, we have observed certain bans from New York, New Jersey, and California states regarding natural gas consumption for the new buildings.
Yeah.
And then the question was, all right, so what are the impacts? What are the outcomes for the homeowners? What are the outcomes for the contractors? Long story short, for those new constructions, especially for domestic hot water generations, they have to go for electrification. But what will be the solution? So again, this was the question. And on the other side, we all know that A12 transition is not going to happen within one sequence, right? So we are looking future somewhere around 2029, most likely another round. as per the AIM and as per the Kigali Amendment. So in that regards, the GWP level, if you look at the rules, most likely it is going to be less than 150 GWP. So, which is the second question. All right. So the first question was, what might be the perfect replacement for natural gas applications? And the second question is, what might be the perfect solution for the second round of transition, A12 transition, somewhere around 2029? And the third question was, which is impacting today, right? So we all know that A12 systems requires more intention from multiple sides, from manufacturer side, from engineers, from contractors, from inspectors. There must be some calculations and all those type of things. So the best solution is not to use those refrigerants. So you can keep those refrigerants outside of your building. But how? Again, it was the third question. So Hitachi was the perfect solution for all those problems. With Hitachi monoblock system, you don't have any refrigerant inside of your building.
Exactly.
This is number one. So even though today, even after 2029, if and suppose hypothetically, if you decide to use propane, which has a lower GWP, lower than 150, flammability-wise, it may not be the best refrigerant, but the thermodynamical characteristics-wise, in regards to cooling and heating, it is way more better than majority of the refrigerants, conventional refrigerants. So in the case of Hitachi, whenever we keep the refrigerant outside of the building, again, it might be a great solution. And the second thing is natural gas, right? So again, today we are consuming natural gas for multiple areas, for heating and for domestic hot water generation. But in that regards, what will be the solution? Again, Hitachi, because with Hitachi system, with monoblock air-to-water heat pump system, you can generate hot water in a closed loop. You can utilize that hot water to create domestic hot water, and you can run that hot water from your fan coils and you can warm up your house. So that's why we have decided to bring Hitachi line card to USA market, and everything is moving forward. It is the second year that we have announced. I think, Darcy, if I'm not wrong, 2 years ago we brought the system to HRI show, and the last year we had a running system in the booth. The feedbacks are awesome. So mass production, hopefully we're going to go within 2 to 3 months. And we know that it is just the beginning of the journey, because it is a complete new concept for the players in the market. But we do believe that there will be good amount of market size for each and every decision maker in the United States, also in Canada.
I personally believe it's our solution. I had the opportunity to interview Nick Reynolds at the introduction of the Hitachi at the 2023 AHR show, and it really struck the interest because I started realizing, okay, I got to think outside of the box here and thinking about our long-term solutions, and that's exactly what we're talking about. How do we remove the refrigerants from indoors so we don't have to be concerned with our flammabilities or our toxicities and the higher operating pressures? How do we rethink and re-engineer residential systems? And it's very simple. We just look at our commercial applications. That's all we do. Exactly. So we move a heat pump chiller into a residential application, get rid of the refrigerant lines. Voila.
So the conceptually it is 100% correct. But the beauty of Hitachi is it is perfectly designed for contractors, because as all we know that, I mean, if our starting point is commercial heat pump chillers, in order to commission a heat pump chiller, you have to have people who will, circulate the pump. You have to deal with that kind of,
right. Design the circulation.
Exactly. On the other side, you have to have a kind of proper engineering background in order to come up with the controls algorithm. BMS is. I mean, with the commercial heat pump chillers, they are awesome. We love them, but it will require multiple type of the teams integrations, right? So you cannot. Sure. It is not like kind of plug and play solution. With Hitachi, it is something like that, because in Hitachi system we have our own integrated centrifugal pump. This is number one. All the refrigerants outside, you don't need to deal with leak sensors. You don't need to deal with shut-off valves, because all the refrigerant is outside. And for instance, for different type of applications, because hydronic growth is endless, we all know that, right? So you can come up with a domestic hot water generation system for a restaurant. You can only target for, good amount of domestic hot water tanks or 100% electrification, or you can come up with a residential application. In that regards, you will need one cycle for condition, right, ambient conditioning, and another cycle for domestic hot water, right? So all these type of cycles means somebody needs to control them, right? Somebody needs to control the system. Somebody needs to
monitoring the automations.
Exactly, meet the expectations of the end user. So in that regards, do we need a kind of controls engineering involvement? The answer is no, because Hitachi is coming up with a plug and play, a PCBA, right? So the contractors can use signal wires, connect them to the outdoor unit, and then they can program everything by using Hitachi's controller. So it is a pure plug and play solution. So that's why we do believe the acceptance is going to be way more easier than all the other type of disciplines.
Yeah, I completely get that. Whether we're talking about residential or commercial applications, we have to get comfortable with water in our industry. I mean, as HVAC technicians, when we look at our two primary industries we're talking about that are making transitions, we're talking about HVAC refrigeration, and we're also talking about plumbing. And for the plumbing sector, it's a very significant leap to move into inverter technology, to move into controls and automations, where if you talk to an HVAC refrigeration or building automations, you're talking to people who have already been introduced into the technologies. They just have to step outside of their mentality and go, well, correct, I can do this with water now as well. Right. And I'm really not transitioning very far. So it makes sense for the HVAC refrigeration industry to be the movers forward of this technology and to start embracing it a little bit.
Absolutely. It is not 100% designed for HVAC folks. It is not perfectly designed for plumbing world, but right, both sectors can jump in and try to come up with their own type of applications, because these line cards, let's be clear, right? So this type of products has been sold in Europe for last 2 decades, we can say.
Wow.
Our experience is from both industries, right? From plumbing and from HVAC, from both these industries, all the contractors are trying to be the part of this trend. But you are absolutely right. HVAC contractors, I can say, they are way more motivated to be the part of this type of transitions, because they are capable to come up with heat load calculations. They know the building codes. I don't want to say way more better than that, but let's say that they are more experienced.
Yeah.
Yeah, exactly. So it is a great transition for multiple sectors.
It is. And we really have to be realistic. When we look at the Kigali Amendment, when we look at the Technology Transition Rule, when we look at the AIM Act, we recognize that we're going through a pretty steep HFC phase down in actually a short period of time. I personally don't think we're going to make it to the 2036 phase down of HFCs. I think we're going to need to get there much sooner. I think the reclamation factor is going to escalate our need to look at low GWP refrigerants and to move the refrigerants outdoor, where they're not involved with the interior building codes. And I think that Hitachi is that first step to get people comfortable with, all right, these refrigerants. Now let's use these refrigerants for a slightly different purpose. And then as we move forward, at some point we'll go, okay, now you know how to condition water for heating and cooling purposes. Now let's use a different refrigerant, and now we can make this final transition into natural refrigerants very smooth and very easy. So I'm a big advocate of the direction that you're going with it.
Absolutely.
Excellent. All right, Enes, Bahadir, I thank you so much for joining us. I'm grateful to have the time, and I look forward to seeing the Hitachi facility here in the near future, and appreciate what you're doing for our industry.
Absolutely. Really honored. Thank you so much.
Thank you so much.